Hello, everybody. Welcome to our 8th free webinar in the 2021 Smart Building Series. Hope everyone is doing well out there. Today, we are talking about the case for an open IoT data fabric for smart buildings integration. And I've been joined by Rich and David from Dialog Semiconductors. And we're going to be discussing the recently standardized IoT Access Protocol and how it may solve some of the issues that arise from systems integration. Another part as well, like in this webinar, we're also going to discuss an example case study of LoRa sensors using this SmartServer Edge running IAP. So I think it's going to be a really interesting topic today. I hope you will engage, all of you, and we'd be very happy to take questions. So the way we kind of work it here, if you do have questions, you can type them into the Q&A box, which I think will be on the right-hand side down at the bottom of your screen. And I'll be able to take them here. And after the presentation is finished, then we'll take those. And then beyond that, we are recording the session. So it will be up online probably tomorrow. So definitely, if you enjoy the content, I'd encourage you to share it with colleagues. Share this interesting presentation. So with that in mind, over to Rich and David. Hi, guys.
James, thanks for having us. It's nice to be here. I appreciate you hosting. So just as a quick intro, my name is David Sciarrino. I am the IoT sales manager for the Industrial Edge Computing Division over at Dialog Semiconductor, and we were recently acquired by Renesas, hence the additional logo at the bottom of the screen. I've been in the smart buildings industry for over 20 years, and I've spent the last year or so working with the Dialog team on IAP and some of the products related to that. And so happy to discuss what we're doing today, and I think it's a really interesting topic. And Rich, I'll turn it over to you to do a quick intro as well.
Thanks, David. This is Rich Blomseth. I'm Director of Product Management for the Industrial Edge Computing Group within Renesas as well. I've worked during my entire career in controls of various types and networking of various types, with quite a bit of it in building controls, but other sorts of controls for industrial control and smart cities. So many different applications. So quite excited to talk about that today. So go ahead, David. So what we want to focus on is a big issue we see in many environments, not just buildings, but smart cities and factories, and that's that the expansion of the availability of different types of technology, the integration of those different types of technology is really driving the cost of installing any kind of smart system. So for example, in a building, it used to be each of these little systems or big systems in a big building were, very independent of each other, right? So the HVAC system was independent of the security system, was independent of the lighting system, right? And so each one of them was sort of the small integration project. But what's happening with the introduction of IoT and the availability of many more kinds of smart devices, now there's many sorts of systems that need to get integrated together, right? And so an example in a smart building, or you see all the systems on the left, things like HVAC and lighting and security, fire safety, and they may be using underlying different networking technologies. Some may be using BACnet, some may be using LAN, some may be using newer technologies coming out with IoT, such as Bluetooth or Wi-Fi or 5G. And so integrating all these things together is quite a challenge, right? And that challenge translates into cost. So the cost and time required to put these systems in is really going up. And that's made worse by the fact that, these protocols are all quite different. Some are legacy protocols that have been around for years. Some are new protocols that are just coming out. And the fact that there are different kinds of systems means we're trying to integrate different kinds of applications and different kinds of products from different vendors into one system. And the scale becomes enormous, especially for a big building or a big factory or a big city. It's quite an industrial scale. And yet you want a system that's available, you want it to be reliable. And there's always a question when you're networking products, who owns the data, who owns the infrastructure. So all these things come together to drive cost up and to make the challenge of getting all this data into common applications, creating applications that provide the information that the user needs, and integrating with cloud services to do all this is what we see as the big challenge. So next slide, David. So we want to make a case today for a very IoT-centric data fabric, right? And we want to provide a solution to this integration problem that utilizes a common data fabric for the IoT that seamlessly connects any endpoints within a system from any kind of IoT device, where an IoT device is just anything that's kind of smart and that can talk to other devices, and connects them to each other and connects them then to applications like artificial intelligence applications or machine learning applications. And we want to provide access to device data securely. Security is very important for many of these systems, but with a web-friendly API that can be used from anywhere. And we want to, by doing that, we want to enable a resilient, decentralized edge computing architecture that can run anywhere. And so we'll talk today about IAP. IEP stands for the IoT Access Protocol. It's an open CTA standard, recently standardized, called CTA 709.10. And we're working on standardizing that same protocol, both with ANSI for the American National Standard and CEN for European Standard. So you can see what IEP is. It accomplishes these things, but it does that by communicating with all the edge devices, all the cloud applications, all the systems, and bringing that data together. So let's go to the next slide, see how we do that. So here's an overview of IEP, right? And IEP is this, an entire diagram here. And that's what's key about IEP is it provides these sort of 10 essential services shown here. And it's the combination of those things that's so important to solve this IoT integration problem. So at the core in the middle, you see there's a core of IEP, which is based on MQTT, and which is an IoT standard method of having services, applications talk to each other. So IEP uses MQTT as a messaging bus, as a way to connect all these various things together. But then on top of that, we wrap all these other services around IEP in a standardized interface through MQTT. So starting at the bottom, you see the edge protocol drivers, right? That's the core of any kind of control system. The first thing you have to do is get the data into the system. And IEP is designed to be independent of the underlying protocol, independent of the underlying data encoding. And we've done adaptations of IEP to many protocols, as you see here. There's BACnet, there's LAN, LoRaWAN, Ethernet IP for industrial applications, Modbus for both industrial and building applications, and very importantly, custom drivers, so that anyone can create a driver for IEP to bring it into this infrastructure that we'll describe. But then going to the left, what IEP does is it provides data abstraction. It takes all this data that's coming from all these different places, but puts it into a common model. And by having a common model, that's going to enable all the other pieces as we go around the pie here. And the data abstraction can also leverage other standards such as Project Haystack, which has a very nice standard tagging models for tagging data so that it can be recognized more easily by applications and clients. So that's the first step, is the data abstraction. So then we go up the chain to the information model. Because just understanding data isn't enough, right? You really have to understand, well, what's the data mean, right? If I have a temperature, what's that temperature represent, right? So the data abstraction is going to say that is going to provide a temperature in a standard format and standard scaling and standard units. But we need to know for a temperature value, is it a return air temperature? Is it a supply air temperature? Is it an outdoor air temperature? It's very important where it comes from, because we can't create applications without knowing where the data comes from and how it's used, right? And so the information model adds that information and creates a digital twin of external devices. And so the digital twins basically represent the inputs and outputs of a device, but keep the information about what those inputs and outputs mean, how they're used. Then we move up the chain to data logging and trending. We need a standard way then of storing that data over time, right? So if I'm collecting temperature over time, I want to know, what are the trends? Is it going up and down? If I'm monitoring energy, what's the energy doing? And then we go to the top, the external client servers, right? So now we want to make all this data available to other clients, external to some gateway that's collecting all this information. And we have standard protocols for doing that as well, right? So the protocols are IEP itself, right? Because since it's based on MQTT, it could be used both internally within an edge server, but also externally to talk to external clients, just using the same protocol. And we have 3 different protocols that are used: MQTT, REST, which is a very standard web service protocol, and WebSocket is also standard web services, high performance web services protocol. But importantly, we can also take that same data and interface to other clients using other protocols such as BACnet IP or OPC UA. And so all those are the external client interfaces. And then on the right side, there are additional services that we provide through IEP, that IEP provides, right? First is scheduling and alarming, so standard services for scheduling things to go on and off or go to different levels or different states at different times of the day, and alarming to detect alarm conditions within a system. But that's not enough. Not having just the applications and the data is not enough. You also need to be able to create these networks. Otherwise, we're not going to solve the integration problem. So the next step down is network management, a standard way of actually integrating devices together, getting them to talk to each other, getting them to work well within one single network. And then finally, health monitoring, which is standard services then for knowing is a device available or not, right? And if there is a problem with the device, informing other applications and services, and ultimately the user that the problems are there. So next slide, David. So let's look at an example of what this enables. So here's an example of using IEP to connect to the Google Cloud platform, right? Because one of the great advantages of using these IoT standard protocols like MQTT is that we can leverage IoT tools. So this tool is NodeRed, which is a tool originally developed by IBM's IoT research group, but they've since open sourced it. So it's a very popular open source tool for basically connecting IoT devices to themselves, but also to other services, which is really what IBM wanted it for. And so in this case, I'm showing an example of some it's just standard NodeRed nodes being used. On the left, the purple nodes, those are MQTT connectors, right? And it's just standard MQTT connectors, but by putting in the appropriate IEP topic, we can actually collect very specific data from an edge server that's serving that data up, right? And so just a couple boxes, we get that data into it. There's some standard function nodes, the orange nodes in the middle for sort of filtering data out that we're interested in. And then on the right, though, is where it gets very interesting, right? On the right is a connector node that's available for connecting to the Google Cloud platform. And again, it's a standard node. You just install it from Google Cloud. And now you can push data into the Google Cloud network. So by putting these few boxes down, connecting them together, we now have a complete application that's collecting data from a live system and pushing it out to Google Cloud. And you can do that with any kind of IoT service, and any kind of IoT service on the right, any kind of data points on the left. And there's lots of processing capability built into NodeRed as well. So if you want to combine data, make decisions based on different data, you can do that as well. So this is really what a standard protocol on top of MQTT really enables, is this sort of capability of leveraging outside tools. So let's go to another example. Next slide, David. So this is a second example, also based on NodeRed, but this one comes from one of our partners who's created their own open source tool set for building user interfaces, HMIs, for building control systems. And so they also used NodeRed on the left, and IEP, which is coming again from the purple nodes. But they created their own user interface nodes. All the nodes in the middle were were nodes that they created for creating visualization tools, and those run within NodeRed, because NodeRed has this capability of building up dashboards and UIs right within NodeRed itself. And so on the right is one of their example user interfaces that's being driven by that diagram on the left, but this is on the right is what the user sees, right? So they see a nice diagram of their system in operation with real-time temperatures being shown and lots of detail on the temperatures being shown. But again, this is something that's enabled by using MQTT with open standard protocol on top of it. Next slide. So with this, I'll hand it over to David.
Thank you, Rich. Appreciate it. So Rich did a great job kind of talking about, what is MQ, or what IAP really means, and how it's used. What we want to look at next is, what does IAP look like when you deploy it in a smart building infrastructure? So to start off, I've got some building systems at the bottom, and I want to kind of build our smart building technology stack from the bottom up. So pretty typical systems: your fire, your HVAC, your security, lighting, and so on. And each of these systems, they have devices that are reliant on something that's further up in that technology stack. So we call that the device level network. So these could be sensors, they could be end devices, and things like that. And then moving further up the stack, we call this the building level network. And just for simplicity's sake, I know there's a lot of interpretation that we can take on what does a typical smart building stack look like, but for example purposes, I want to keep it fairly simple. So at the building level network, you've got protocols that may be more Ethernet based. Sometimes you end up with some proprietary protocols, but as you can see, there's a huge variety of different protocols and different technologies that come into play, in this environment. And then moving up, one level further, you've got what I call the management level network. So this is where you have your user interface, it could be your BAS controls server. In some cases, there isn't really anything at that level, and these devices push straight to the cloud. So when you look above that management level network, every technology stack here really runs independently, and they may have a cloud connection. So that cloud connection is usually owned by the owner of that technology stack. The HVAC supplier for this building may not even know who the security integrator is. These systems don't talk to each other typically. They're not aware of each other's presence. So each cloud, even if they do have cloud connectivity, it's also completely independent. So these systems can't take advantage of the fact that they have information that could be leveraged from one to the other. So when we introduce the common data fabric running on IAP, Rich mentioned that we're really creating a digital twin of that information. So we have to get that information into that data fabric layer. So we start making connections. Rich talked about the various ways in which we can do that. Sometimes you need to make that connection at that device level network. Sometimes that needs to be at the management level network, or sometimes even multiple places for one technology stack to get the information that you really need. So and like Rich said, IAP really isn't just it's not a transfer protocol. Protocol may be a little deceiving of a name, but what IAP is doing in a case like this is it's creating the framework for a fully integrated building operating system by creating that interoperability between what used to be multiple disparate systems within that building. So if we look at it from a slightly different perspective, so if we look at IAP from its own perspective and what it sees, the network architecture looks a little bit different. So we can still show the device level networks. Now we see these individual sensors, they may be meters, they could be various IoT devices talking on any number of different protocols. And IAP sits right above that at that building level network. So IAP is going to reside on an edge server of some kind. From this perspective, IAP is really not just a gateway to these devices. Like Rich said, it adds the contextual information and the standardization as well. So in addition to connecting directly into those device level networks, you've also got your systems that actually sit on that building level network. So we're making the connection bidirectionally to those systems as well using IAP. And then at the management level network, you may have multiple user interfaces. That connection is also very important, because a lot of times you'll have information that's available there that you may not be able to get at the building level or the device level network. So with this information, we're able to do things that create more of an application development environment at the edge. So that becomes very important when we're working with a software developer, a solutions provider. They want to leverage the fact that we now have data from multiple systems, all in a common data layer. It all looks and feels the same, regardless of its underlying protocol. So the next step is using some of the transport protocols that Rich mentioned, like MQTT or the REST API. So you can now take this data that's now been normalized, it's been standardized, and you can push that directly into any cloud environment. So that enables anybody's cloud platform, whether it's a machine learning or AI application, or even if it's an enterprise application for a specific end user. They can access that data in a way where they can make sense of it without having to do anything with it on their end. So a few examples that I like to talk about when it comes to what can you do now that you have multiple systems on a common data layer. A good example is taking an intelligent lighting system that may just be dimming and controlling based on occupancy and light levels. Now maybe you have a fire alarm system that you've integrated to, and a lot of people say, why would you want to integrate those two things? So a great example is creating a specifically lit egress path during a fire alarm event. Now that your lighting system can understand what the egress paths are, and when there's a fire alarm, can direct people to an exit more efficiently. You could even take a presence or occupancy detection system or people counting system, use that as an input to your HVAC BMS. And now you have an understanding of where are the spaces being utilized, what do I need to do in those spaces, from an occupied or unoccupied set point standpoint. Or even a smart grid application where you have live meter data that you can now interact directly with any of the green energy generation assets on a site, and you can manage consumption and generation in real time. So it helps you control peak demand, and more importantly, if you take these kind of examples and then you zoom out and you look at it from not just the building standpoint, but look at it from maybe a campus standpoint or a city standpoint, you now have multiple buildings that can potentially interact with each other because they're all collecting the same data and they're collecting it the same way, and it looks the same across the entire portfolio. So one of the use cases that James mentioned that we wanted to talk quickly about was integrating using the LoRaWAN solution into legacy systems. So this is one that we've used considerably, and our partners have leveraged quite heavily. So in this example, we see an existing BMS system on the right, and that there's a need for additional building data to be put into that system to help drive efficiencies, energy savings, could be indoor air quality, various different applications. Everybody knows there's it's an uphill battle when you want to go install a new wired system into an existing occupied building. It's costly and it's disruptive. It doesn't usually make sense. LoRaWAN has been a very good solution because of a very wide variety of sensors available that can connect wirelessly. In the past, these sensors typically would connect through, a wide area network and get data pushed up to the cloud. That would be part of a SaaS model where you're paying to get that data, and you can access that data online. But you really want to do something proactive with that data. So what we've done with IAP is we've enabled it to digest the local LoRaWAN data without actually having to go to that wide area network. We could ingest it directly, on an edge device, and that data can be pushed out directly on premise, to an existing BMS, whether that be BACnet, OPC, LawnWorks, or Modbus. So the local BMS now has a whole slew of new sensor data available to it that can now be leveraged to achieve some sort of outcome. So we've seen some very interesting projects get completed very, very quickly using this approach. So it is, for me, it's a fun one because it opens the door to a significant amount of additional solutions that maybe weren't really accessible to a lot of customers, and when they were just priced out of the market when it comes to doing a full retrofit. So this is definitely technology to watch. Very common in the UK. It's starting to be more of an emerging technology in the US. So something to definitely keep an eye on. So the next slide, I want to turn it back over to Rich to talk a little bit about the future of IAP.
Thanks, David. That was a great overview of the application of IAP. And so the future of IAP is now an open standard. It's been standardized by CTA. You can see it here on the left on their website. It's CTA 79.10. They've forwarded the standard to ANSI for ANSI standardization, which is the American National Standards Institute. And we're also working with CEN, which is the European Standards Group, to standardize, make it a European standard as well. And once we have both European and American standards, then we'll move on to ISO for international standardization. This is really the same path that the LAN protocol took, where LAN started as a ANSI standard, then a CEN standard, then a standard in China, and then became a ISO standard. So we'll do the same thing here. You can see a documentation for IAP and learn more about it at the website shown here, icdocs.diasemi.com. So all the documentation is open, freely available, and you can read about it. And you can also see actual source code examples and configuration file examples at the GitHub repository shown on the bottom of the slide. So with that, I'll turn it back to David.
Yeah, I think we're ready to start taking any questions. So, James, do we have anything queued up?
We don't actually. So please feel free, everybody. I think we've covered a hell of a lot of ground there. So I must be some questions out there about how it works and where it came from, how it could be used in the future. Please put your questions in now, and we can take them. But I mean, I can obviously get the ball rolling here. I mean, it's fascinating. It's actually, when we started talking about doing this webinar, it was something that's entirely new to me. I hadn't come across IAP before. I mean, what was its genesis? Like, where did it get its, how was it developed?
The genesis of IAP?
Yeah.
Yeah. So, we've been working within my previous company was Echelon, which created the LAN protocol. Mm-hmm. And that was acquired by Adesto, and that was acquired by Dialog, and now by Renesas. Right? Yeah. But as part of Echelon, we've been working. Well, we helped create the IoT market in reality, right? I mean, that was really the original vision of Echelon. Right. Mike Markula, who was the founder of Echelon, was to create what is now known as IoT, right? He thought that we could push intelligence down into every edge device and have them talk to each other. That was sort of his vision, and that was something that wasn't being done at the time. And so, Echelon kind of created that market. And then early on, we created an edge server that could talk to all these devices and provide that data to cloud applications and enterprise applications. And we did that many years ago. That was like 15 years ago, 16 years ago, that we created that product. And so we learned a lot from that product, and that was really the first SmartServer, right? And we learned what it took to get devices to talk to each other and to talk to different kinds of devices, because the SmartServer was more than LAN. It could do Modbus as well. It could do BACnet as well. Mm. And so we learned how to do that, and we decided we needed to create a new generation of that to more leverage IoT technologies. And so IEP came out of that effort to create a new, more IoT friendly, IoT centric solution for talking to a variety of edge devices. And so we developed IEP pretty much from scratch, but really looking closely at other IoT protocols that were available, other IoT technologies like MQTT that were available, to see how we could best leverage all that. And that definitely very much leveraged the beautiful data model that LAN had created, right? That LAN, working with LANmark International, had created this incredible data model with many standard types, many standard profiles. And so we were able to integrate that tightly into the IEP. So IEP really is born of LANmark data modeling and information modeling, but also of IoT standards and efforts.
That combination of those two things. Yeah, I think, no, it's fascinating. And as I said, I think that's you guys did a great job of giving an overview of it. I think one thing, I'll make an observation and then we can take some questions. I think it was the overview slide, like the third one, and you talked about this common model, which I thought was really interesting, right? And you kind of likened it to a digital twin. I mean, I'd be really interested in that process, like how. Could you talk a little bit more about like how IAP does that?
Yeah, so we do that by adding information to the data, and then the information really is more information about the device that is contained within, right? That's how you create a digital twin, right? Is that you have to have a model for what a device looks like, and we break that down into layers, right? So the top layer, you've got the device itself, right? And now you want to create a twin of that device. But then within that device, it has units of functionality, right? We just call those blocks, right? And a block is some unit of functionality. Maybe it's a temperature sensor, right? Maybe it's a temperature controller. Maybe it's a pressure sensor, right? Maybe it's a light level sensor, or maybe it's a lighting controller, right? So there's different blocks within a device. So we call those blocks. They're described by what we call a profile. And profiles are one of those things that get standardized, like through initially LANmark International, but now part of the IEP standard. So the profiles define the inputs and outputs of a block and define what they mean, right? So for example, a temperature controller might have an outdoor air temperature input to it. It may have a return air temperature to it. It might have a supply air temperature to it, but those are each characterized as part of the block. So the block knows that what these three temperatures mean, not just temperature, but also where do they come from. And so that's part of the block definition. And then within the blocks then are the data points themselves. So the data points themselves are those things, those temperature values or those pressure values or the light level values, right? And so that's the model that gets built up, right? And so that what you end up with is a digital twin, right? That you now know you've got this block of data points, but you know what that block is used for, you know what those data points are used for. And that information all lives within it. And
sorry, I was just going to ask, how is that information stored in the relationships between the data?
It's actually stored within sort of the MQTT topic itself, right? So okay. So the MQTT topic, when you see the data, like I showed the examples in NodeRed, what those topics look like. Yeah. When that data comes into an application, it has a reference to the device, it has a reference to the block, and it has a reference to the data point type and data point. And there's other topics I didn't show, but there's other topics that have more information about those, right? So basically you take the information from the data point and then you go into these definitional topics that say, well, this particular kind of, say, for example, it's a VAV controller, right? So it'll point to a VAV controller definition, and then you can look at that definition right within IEP, right? It's all stored, it's all available to the applications anytime they want, just by looking at the right topic, right? So yeah, it's all in the IEP data stream.
Nice. Okay. So that's enough from me for now, anyway.
I see a question in the questions from.
Yeah, exactly. Let's get to some questions.
Yeah.
A couple I could probably answer, actually. Can we obtain a copy of the slides? Yes, we are going to put those online. We'll put them they'll be on our website tomorrow, along with the recording. So I'll make sure that. And then someone's asking who the moderator is. Well, that would be me. So my name's James McKell. I work for Memoori Research. So we're an analyst company that covers smart buildings. We're not affiliated with this in any way, but we do and have been doing a lot of webinars, for educational purposes. So that's what this is. And then the question, can you say a bit more about how you utilize Project Haystack? How would you?
Yeah, absolutely. So as I mentioned, what we're doing within the IEP data stream is adding information to the data point itself, right? Because as we all agree, the data point by itself isn't enough. We need to know more about it. Well, a very nice thing that Project Haystack has done is define sort of a standard set of tags for tagging data points, so that other applications can recognize what they are and get more information about them. Sort of the same objective we have in building up our digital twin. So we have the capability of adding tags to data points also that run sort of in parallel with what I described in my answer. And so those tags can be Project Haystack tags, right? And so by using the Project Haystack tags, then that applications that recognize those tags can get them along with the data and then use them to interpret the data, just like any other Project Haystack application would do.
Mm-hmm. Okay. And some more questions coming, some good ones as well. So our next one would be, what are the key steps in implementing an IAP solution in an existing building, including key considerations to determine requirements and required IT infrastructure?
Well, the key steps are first to sort of characterize the devices in the building and what they can do, right? And so I mentioned we have a SmartServer that implements IEP, and so the SmartServer can be told, what are the devices you want to talk to, right? So you characterize the devices both in terms of what sort of protocols they're using, but also what kind of data do they have, and organize the data as I was describing. Mm-hmm. And then you put those definitions into the SmartServer, and in some cases it can discover that information as well. So for example, with BACnet, you can point it at a BACnet device and it can learn by talking to the device what it's capable of doing. So once you sort of define those devices, and then you tell the SmartServer about the physical devices themselves. You say, here's the devices out there, or you tell it to go discover them, because it can discover BACnet and LAN devices. Actually, even Modbus devices, if you characterize them enough, it can discover them too. So now you've built up sort of the definition of the devices, but now you have the devices themselves. And you can think of that as getting the digital twins into the SmartServer, right? So now the SmartServer has a complete understanding of the system and references to all the digital twins for all the different devices within the system. And then once you have that, you can start configuring those devices, and we make it very easy to do by different device types. So for example, you may have hundreds of VAV controllers within a building. Well, you can characterize how you want to talk to a VAV controller. What data do you want to collect? How often do you want to collect? How long do you want to keep that data for? What are the alarm conditions, once you set off alarms? So you can define all that information for the VAV controller type. and then apply that to all your VAV controllers, right? So that with one sort of simple definition that you create, you've configured all the VAV controllers in the system, right? And you do that for all the different kinds of devices in the system. And so you start building a system up, and the SmartServer starts then collecting that data, storing the data as you've requested it to be stored, watching for alarms as you've requested, right? So very quickly the system becomes operational. And then you can take that system and start integrating it then with your other applications. Maybe you have a BACnet workstation, maybe you have an OPC UA client workstation, or maybe you have a custom workstation you've created, like the one I showed from one of our partners that's really just running on a web page. And so you start integrating those clients then into the system, and by building it up a step at a time, you have a complete working system.
Thank you.
As far as the required IT infrastructure, one of the beauties of really integrating with IoT is we're just using standard IP infrastructure, right? So there's nothing special required on the sort of the northbound side, right? All those client interfaces, those are just running on standard standard Ethernet, right? Standard LANs, right? So as long as you can get a Ethernet connection to the SmartServer, you've got the IT infrastructure you need.
Okay, and you've referenced SmartServer quite a lot. That's your product, right? That is enabling this this infrastructure.
Correct. Right. That's the Renesas product that implements the Open IEP protocol. So we've just taken that protocol and implemented it onto the SmartServer. But yeah, that's what it is. And
it would be a piece of hardware that, I mean, is that gonna reside in the building or in the cloud?
In the building, right? So we call it an edge server. Right? So it sits at the edge. The idea is it's sort of serving up. It's serving up all this data from all the devices that it knows about. So it typically sits in a building. So in a small building, you may just have one edge server. A large building, you maybe have one per floor. That kind of thing.
Yeah, I don't have one more question about that, but we can come back to that. There's some more questions here. Yeah, one here. Are you working on including, so it's talking about the LoRa WAN integration example you showed. Are you also working on including other simple IoT protocols? And is there a roadmap for that?
Yeah, absolutely. We're definitely working on more. I mentioned that we're actually currently working on Ethernet IP, which is the industrial protocol version of Ethernet. Developed by ODVA. So we're working on that. So that's sort of in our roadmap. And yeah, I don't have a roadmap beyond that. We sort of work on them as we get inputs from our customers. We're also working on a new toolkit to make it even easier to create your own drivers, right? So if you want to create an interface to some new IoT protocol that we haven't done yet, we're in the process. Actually, we've already released a toolkit, but we're improving the documentation of it to make it very, very simple to really tie to tie IIP into any sort of device. So yeah, I think I saw that question was from Matthias, so I can give you more information about that offline with that if you want.
Okay, good. One here as well. What would be the benefits of using IAP or this kind of configuration above something like Niagara Web Supervisor and or a JACE controller?
Sure, I can address that. What we see as the big advantage is really just the openness, right? Niagara is, it is a beautiful solution, right? But it's based on a closed protocol, right? Whereas we're trying to accomplish many of the same sorts of things, but we're trying to do it in a much more open way, right? That's why we're working with CTA and ANSI and SEN to standardize it, because we want to make it freely available to anyone who wants to use it. And if someone wants to implement their own edge server, they can, right? There's really nothing that restricts someone from doing that. So that's really the big difference.
Okay, good.
Rich, just to expand on that a little bit, Rich. We've had a lot of customers and partners that they primarily use a Niagara supervisor, and they're using IAP as a tool to push data into Niagara Supervisor, very similar to the way a Jace would do that. So it does that using BACnet IP or WebSockets. So it's just, instead of Fox protocol, it's just an alternative to that same approach.
Maybe worth, for those that might not know, describing what would a Jace be? That's is that like a gateway box?
Yeah, it's a edge server also. Yes.
Okay, got it. A question here about the edge server. Can the edge server interface with 5G devices? And again, is there a plan for that going forward if it doesn't already?
Well, that's a most excellent question. We're actually working very closely with a 5G provider right now, so I don't want to talk about names, but yes, you can do that. We're working on working with them. They have a box that has a built-in 5G interface and has a processor with enough power to easily run the SmartServer software, right? So we're sort of integrating our software with their box and creating a 5G solution that it's a very industrial 5G, right? So it's really suitable for embedding either within a building or within a factory, right? So it's a factory level solution. So yes, we can integrate with 5G. We have done that integration in our own prototyping, have it up and running, and it's working very well. So it is a very good combination of technology of using 5G to create a wireless connection that can span very large areas.
Nice. Yeah, that's good. There was another sort of comment here in the chat about slides. So just to let everybody know again, we will put these slides online, which you can use as reference, and there will be a recording as well. So yeah, I guess that will be useful as a reference point going forward. And obviously those links will to some of the documentation. We can put those into the notes on our website. So some more questions here. How does the system support writing back into the controllers? For example, controlling lights in the case of a fire event.
Yeah,
sorry, go on.
Yeah, that's another, I think, great question. Yeah, he also asked where the decisions being made and how are they communicated. So yeah, that's a very important part of IEP that yeah, I should have mentioned that yeah, it really is bidirectional. I know there's some protocols out there that are more focused on just collecting data, but we're focused on both directions. We're focused on collecting data clearly, but also sending control information back to devices, because most control networks, yeah, both are quite essential. And so all the interfaces I was talking about, they're both bidirectional interfaces, so we can read and write. As far as where the decisions are made to do that writing, yeah, that we don't dictate where it comes from, as far as who decides to write to a data point, right? That's part of the definition of the system that the integrator does, right? But the decisions can be coming directly from the SmartServer. We've created the SmartServer as a programmable platform, right? So we don't restrict users from adding any of their own applications to it. They can. And we've created this tool. I showed the tool based on NodeRed. NodeRed is a great tool for actually controlling devices, not just monitoring them, right? And so you could, for example, bring data into a NodeRed flow, like I was showing, make decisions. Say if a temperature goes over a certain value, you want something to occur, make that decision, and then have data points right within the flow that you control from the flow, based on the decisions that you program in. So that's an example of making the decision right within the SmartServer itself and pushing the data back out to the devices. Or if you want to push information to the cloud, make a decision within the cloud application, then the cloud application can come back and control devices. Mm-hmm. And you probably wouldn't do that for real-time control, but you might do it for supervisory control, right? And then also mention some of the built-in services like the scheduler. The scheduler really is a controller also, right? It's really just a time of day based controller. And so the scheduler is making decisions about what to write to devices, and then at the scheduled times, it writes that information out to the devices. So you can do it, from custom applications or built-in applications or external applications. So we believe all are important.
You mentioned NodeRed a few times, and obviously I picked that up in the presentation. Again, very interesting, like open source. Sounds like a very powerful kind of tool as well. I mean, is that easy for somebody to pick up and understand how to use it effectively?
Yeah, it's IBM did a great job of designing it, because they were trying to solve the integration problem for themselves, right? Because every time they got a new IoT device, they had to write custom code to talk to it, and that was just too much work, right? So they did a good job of making this tool, and it's become very popular. And one of the great things about it, being a popular open source tool, is there's a lot of YouTube videos about it, right? So
yeah.
If you just go on YouTube and type in NodeRed, you'll get tons of training, and it's very easy to pick up. A lot of those videos will take you, step by step through, creating different kinds of flows. And we have some of our own as well, right? So we have videos too, that's on the documentation site. I had a link to the documentation site on one of my slides, so you can go there and see our videos, but you can also go to YouTube and find lots more.
Yeah, and I guess then the other advantage is that it's well supported, I guess, in the sense that, if it's being updated and patched.
Yeah, and it has this huge community behind it, right? So you can go to their website and actually search for nodes, all those little boxes I showed in the flow. So they call those the nodes. And there's lots of standard nodes available. It comes with quite a few just built into it when you first install it, but you can also go to the website and search for more and find lots more. And especially if you want to find cloud connectivity to different kinds of cloud services, you'll probably be able to find find those
out of the box, right? Like connecting to AWS or whatever. Yeah,
exactly. Yeah.
So got couple more questions here, but anyone who is keen to get a question answered now, please type it in, because we're going to run out of time. So I'll get on with it. Is there a limit to the number of devices that the edge servers can communicate with, and can it be set up to auto detect new devices that are introduced? That's I was going to ask that. It's a great question.
Yeah, I can address that. So yeah, there is a limit. It's really more of a performance limit. We don't have a hard limit, but we say the performance limit is probably somewhere about around 1,000 devices. And then also we license based on capacity, right? So depending on what capacity license you purchase, that you're going to be limited to that, right? So we, for example, have 1,000 device capacity license, but we also have smaller licenses if you have a smaller system, like I don't know, 100 or 200 device capacity license. So there ultimately is a limit, and then there's the licensing limit too.
And this, they got this auto detect feature. You kind of mentioned that. I thought that was interesting as well. This, I guess, discovery, right? Is it able to, let's say, I don't know, let's say it's installed and running. Like if you added new devices, would it be able to detect them automatically?
We don't have auto detection where it just automatically discovers it as you plug a device in, right? So basically, there's a discover button, right? And
yeah,
okay. Looks like a play button, right? And so you click the discover button, and then it just automatically goes out and looks on all three protocols, and LAN, BACnet, and Modbus, looks for new devices. So not fully automatic, but pretty automatic.
Yeah, I'd say so. Okay, another question here then. Again, I think this is on the 5G topic. Do you plan to license the SmartServer IoT software to run on other hardware platforms, since it is runs on a Linux box?
More great questions. Yeah. So let me answer the second one first. So yes, we are running on standard Linux. It's Ubuntu Linux. We've just moved recently to 2004. Yes, we do have plans to license the software to run on other platforms. We want to make it very, very widely available and possible to run on different platforms, and we're looking at multiple architecture platforms as well. The SmartServer is a ARM ARM architecture processor within it, but we ultimately would like to make the software available both for ARM and x86, since you can get some pretty high performance boxes with the x86s. So yeah, so we're definitely working on that. We'll probably do it through some sort of container strategy where we can deploy the software through containers.
Mm-hmm.
So that's a very active project for us right now.
Nice. Okay. Yeah, no, I think this has been a really interesting presentation, and I've learned a lot anyway. So no, I think anything that is open and is helping to solve some of these integration issues, then I think it's great. I mean, in terms of like, people who are going to find this most useful, I mean, do you think this is going to be aimed and really hit the spot with like integrators and systems integrators? Is that where you'd expect your customers to come from?
Why don't you take that one, David?
Yeah, so we do have some integration partners. They're mainly the master systems integrators that are really more heavily into software. But we do work with several OEMs who are building their applications, using IAP. And those range very widely, from just your typical smart building solution to some of them it may be more of an industrial, manufacturing type of equipment relationship. Using IAP. So because it's completely open and it provides an application development environment, software providers who are looking to really deploy their software either in a building or for a particular use case tend to leverage IAP pretty heavily because of the ability for them to easily deploy their software, and they don't really care about hardware. It's a means to an end to them. So they need the easiest possible way to deploy their software and get the data that they need to support it. So the software integrators are very front and center for us as well. Yeah, no, that's great. And again, like I think this is a great initiative, and I'm sure tools like this are just really going to be really useful for people because solving issues that I know have sort of been long standing within the smart building industry. So I mean, are there any sort of final points you guys want to finish off with? Perhaps where people could go for more information, or if they wanted to contact you directly with questions? Yeah, so I think we've got our contact information, at least our email addresses on the first slide that, again, will be posted. So we love having these kind of conversations with people. This is the world that we've lived in for the past, few decades. So, we're open to any kind of conversation about, how we can maybe leverage IAP or potentially partner with anyone. And also the website information was also on some of the slides that Rich referenced. So quite a bit of information there, and we'd love to have a conversation and talk more about it. Good stuff. And as I said at the start, we have been recording the session, so I'll make sure everyone who's been listening in will get emailed a link to that tomorrow, so you'll be able to pick that up. And also, or if you just go directly to our website, memoori.com. You'll see it tomorrow. I think, well, that's pretty much it for today. Just remains me to say thanks, David. Thanks, Rich. Really enjoyed that. Very kind of in-depth description, and I think it was very useful for everybody. Thanks. Yeah. Thank you. Well, fun discussion. And thanks everyone for listening. We'll be back next month with another webinar, and check out our YouTube channel. There's also some podcast interviews on there as well with various industry people as well. So yeah, thanks everybody. See you all soon. Bye-bye.
Bye.